Lead nitrate reacts with, this is asked as an observation question. What happens when this dilute HCl is added to lead nitrate solution? And there's an extension of the question. HCl is added to lead nitrate solution and then heated. So on heating, this has a very funny, very typical characteristics. This is the chloride which is soluble in hot water, insoluble in hot water, and soluble in insoluble in cold water, sorry, and soluble in hot water. So normal conditions, when you're adding dilute HCl to lead nitrate, you will see a precipitate forming, white precipitate forming in the test tube. Now if you warm the test tube, the precipitate vanishes, it dissolves. So because lead chloride has the characteristic property of getting dissolved, being soluble in hot water, so it will dissolve on heating. So if the question is what means HCl, dilute HCl is added to lead nitrate and then heated, so you will write initially it forms a white precipitate which disappears on heating as lead chloride is soluble in hot water. Another question often asked, this is also a white, both are white PPT, okay? This is also a white PPT, this is also a white PPT. Another question is, what happens, means how do you distinguish, that was an observation question can be asked for both. Another is a distinguish question, means distinguish between HCl and H2SO4, both are transparent liquids, okay, both acids are transparent. You don't, if you are given two acids in two test tubes, you don't have any means of understanding which is what. So what happens here is you are asked a question, how do you distinguish between HCl and H2SO4 using lead nitrate solution? So what do? When you are adding HCl, when you are adding lead nitrate solution to HCl, it gives a white PPT. When you are adding lead nitrate to H2SO4, then also it is giving a white PPT. Then how do you distinguish? If you heat, the one which dissolves on heating is hydrochloric acid. The test tube which has a white precipitate which dissolves on heating means lead chloride is soluble in hot water. So if it is dissolving on heating, that means it is HCl. PbSO4 will not dissolve on heating. Now we will do the bases. Chemical properties of bases. Am I audible? Okay. Soluble bases are, water soluble bases are called alkalis. And the other, apart from the two we did before, neutralization reaction is the most important reaction. The bases are defined on the basis of neutralization reaction only. So bases, apart from that, a very important property of bases, okay, one physical property of base I did not tell you, that is it is slippery to touch. Okay, that is not with the acids. It is very slippery to touch. It forms a soapy solution. Why? Because caustic alkalis, NaOH, KOH, they will react with oil to form soap. And when you are rubbing it and if you touch the alkali, then what happens? The fat of your skin dissolves in it and forms soap. That is why it is slippery or soapy to touch. Another important property is caustic alkalis, they absorb carbon dioxide to form sodium carbonate. It forms Na2CO3, sodium carbonate and water, H2O. So it can absorb carbon dioxide. That is why it is used in soda, lime, etc. used to absorb the moisture, to remove carbon dioxide from any mixture of gases. Caustic soda is used as for removal of CO2. Next property is any ammonium salt, suppose ammonium chloride, any ammonium nitrate, ammonium sulfate, any ammonium salt, when warmed with an alkali, if you heat it, just warm it, it releases ammonia. So this will give NaCl plus H2O plus NH3. Now these are all, I have not balanced it over here. This is 2 Na2CO3 and H2O. Some equations may not be balanced. My aim is to let you know what happens when these reactions takes place. So NH4Cl, and when any of these ammonia, it can be a sulfate, it can be a nitrate, it can be chloride, it can be any ammonium salt, when heated or warmed with an alkali, it will give the pungent smelling gas will be evolved, that is ammonia. Pungent smelling gas, you have to write the test of ammonia. What is the test of ammonia? Not here. If it is asked as an observation question, what happens when a caustic alkali is added to an ammonium salt? Then you will write that a pungent smelling gas is evolved which turns Nessler's solution brown or gives a blue precipitate with copper sulfate solution, or turns to, means these are, you have to write a chemical test. Nessler's solution brown, or it gives dense white fumes with, the gas gives dense white fumes with a rod dipped in HCl. Right. So a test of ammonia gas, if it is asked as an observation question. Now this, then ammonium chloride, ammonium salts. Another we have already done, that it can precipitate out the insoluble hydroxides. If you take a salt solution, this is another FeSO4 suppose, and you add NaOH to it, this will form FeOH2 whole 2 plus Na2SO4. This is a green precipitate. This has a wide application in the analytical applications we will do in finding out the cation present in the solution. So Fe2 plus ions will give green precipitate. This is green, insoluble in excess. If you take zinc, you get ZnOH2 white gelatinous precipitate plus Na2SO4. Now this gelatinous precipitate, zinc, as I told you before, is amphoteric in nature, means zinc oxide, zinc hydroxide or zinc itself, all will be reacting with excess of this alkali, and they will give another series of salts, that is zincate will be formed. So this is insoluble in small amount, white gelatinous precipitate is formed in small amount, but when excess is added, then this ZnOH2 further reacts with this 2NaOH and forms Na2ZnO2, which is soluble. Now that is another chapter of analytical chemistry that we will do in details later on. Suppose copper sulfate you have taken, copper sulfate plus NaOH. This will give a blue precipitate, pale blue, CuOH2. This is a pale blue precipitate. This is gelatinous white precipitate. This is pale blue precipitate plus Na2SO4. If you take NH4OH, then also it will be the same. NH4OH suppose you are taking. Then also it will be this pale blue precipitate. In all cases, if you are taking ammonium hydroxide in place of NaOH, you get the same result. You get the, not in this, sorry, in this FeSO4 plus NH4OH, FeOH2 you will get, but over here instead of sodium sulfate it is NH4 whole 2 SO4. Here also it will be NH4 whole 2 SO4. So this ends the chapter of salts and bases. After this we have pH value. We have pH value.